Okay, yeah. So the first one is like, what is networking? So yeah. So networks are simply things connected. For example, your friendship circle, you are all connected because of similar interests, hobbies, skills, and sort of thing, right? So networking basically is the practice of connecting computers and other devices together to share resources and exchange information and to communicate with each other. So this involves the design, implementation, then management and maintenance of both the hardware and the software components that enable the communication and the data which is being transferred between the devices. So, networks can be found in all the walks of life, like a city's public transportation system or infrastructure such as a national power grid for electricity, then meeting and greeting your neighbors, then postal systems for sending letters and parcels. Okay.
Okay.
Hello, am I audible?
Yes, I can hear.
Okay. So, but more specifically, in computing, network is the same idea, just disappeared, dispersed to technological devices. Like take your phone as an example, the reason that you have it to access things. So we will cover how these devices communicate with each other. Okay. So, there are several types of networks like LAN, WAN, MAN, then wireless networks, then VPNs, and many more, right? So let me just give a brief like LAN, a local area network, is a network that covers a small geographical area such as office building, and it allows devices within the network to share files and other resources. And whereas
Okay.
WAN, wide area network, so a WAN spans a larger area, like typically connecting multiple LANs together. So the internet is an example of WAN as it interconnects computers and network worldwide. And the third one is MAN, which is Metropolitan Area Network. So a MAN is a network that covers a larger geographical area, such as a city or metropolitan area. Okay. It basically connects multiple LANs together using high-speed connections. Okay.
Okay.
Yeah. And the next one is wireless network. So a wireless network uses radio waves, or we can say infrared signals to transmit data between devices without the need for physical cables. So Wi-Fi is example of wireless network. And the next one is VPN. So VPN creates a secure communication tunnel over a public network to enable remote users to access the private network securely. Okay. So
Okay.
when we talk about like networks, so they are integrated in our daily life. Like um, like networking basically involves various components and protocols, which are like network devices, like routers, switches, modems, and access points and network cables, and then IP addressing and protocols like TCP, UDP, and HTTP, then network security. So there are multiple protocols and like components of networking. So we will see, take a diagram below as an example, like Alice, Bob, and Jim have formed their network. We will come on to this a bit later. Okay. So networks come in a shape and size, which is something that we will all also come on discuss throughout this one. Okay. So the first question is like, what is the term for devices that are connected together? So that's network. Okay.
Network.
Yeah. So now we will move into what is internet. So the internet is basically a global network of interconnected computers and other devices that use a standardized set of protocols to communicate and exchange information between each other. So it is a vast network that spans the entire globe and then allows millions of computers and devices to connect and then share data with each other. Okay.
Okay.
Yeah. So the internet is basically decentralized network, meaning that it does not have a central authority controlling or governing it. Okay. Instead, it is composed of numerous interconnected networks, which are operated by various organizations, including like internet service providers, which provide us internet, and educational institutions, then governments and private companies. So basically, it is decentralized network. Okay. And at its core, the internet relies on Internet Protocol Suite, commonly the TCP/IP protocol, to enable communication between devices. So this suite of protocols allows computers and then devices to send and receive data packets over the internet, and the TCP ensures reliable delivery of data packets, while the Internet Protocol, which is IP, handles the addressing and the routing protocols. Okay.
Okay.
Yeah. So here it is written like the internet is one giant network that consists of many small networks within itself. Using our example from the previous task, let's now imagine that Alice made some new friends named Zen and Toby that she wants to introduce to Bob and Jim. Okay. So the problem is that Alice is the only person who speaks the same language as Dan and Toby. So Alice will have to be the messenger. Okay. So, because Alice can speak both languages, they can communicate to one another through Alice, forming a new network. So, like the internet provides a wide range of services and resources, which include the first one is like World Wide Web. So, the web is a system of interconnected documents and other resources, which is accessible through web browsers. Okay, www. Okay, so
Okay.
it allows users to access websites, then web pages, multimedia content, and online services. So the first iteration of internet was within the ARPANET project in the late 1960s, and the project was funded by United States Defense Department and was the first documented network in action. Okay, so it was invented by Tim Berners-Lee by the creation of www. Okay, so let's relate Alice's network of friends to communicate devices. The internet looked like a much larger version of the sort of diagram. Okay, so basically, we connect through internet, right?
Okay.
So as previously stated, the internet is made up of small networks or joined together. So okay, these small networks are called private network, where networks connecting these small networks are called public network. Okay, so these separate networks are like private, and when these networks are connected, it is called public network. Okay,
Okay.
yeah. So devices will use a set of labels to identify themselves on a network, which we will come onto the task below. Okay, so who invented the World Wide Web? So it was here, right? Tim Berners-Lee.
Tim Berners-Lee.
Yeah. And the next one is identifying devices on network. So to communicate and maintain order, devices must be both identifying and identifiable on a network. So what use is it if you don't know whom you are talking to at the end of the day? Okay. So devices on network are very much similar to humans. In fact, so for the identification purpose, our name and our fingerprints are used. So uh, when we talk about like network, so IP address and MAC address are used to identify like the user. Okay,
Okay.
yeah. So we will go through this one by one. So first one is IP address. So an IP address, known as Internet Protocol address, is a unique numerical identifier assigned to each device connected to a computer network that uses the Internet Protocol for communication. So it basically serves two main purposes, like identifying the host or network interface and then providing the location of the device in the network. Okay.
Okay.
Yeah. So IP address comes in two versions, like IPv4 and IPv6. So first, let's split up precisely what an IP address is in the diagram below. Okay. So there are four octets in IP address, each of range 0 to 255. Okay.
Okay.
Yeah. So, an IP address is a set of numbers that are divided into four octets. The value of each octet will summarize to be the IP address of the device on the network. This number is calculated through a technique called IP addressing or subnetting. Yeah. So basically, IP is the number is calculated. These numbers are calculated basically with the IP subnetting or addressing. Okay. So, what's important to understand here is that IP address can change from device to device as it is unique identifier. So, each device has its own IP address, but cannot be active simultaneously more than once within the same network. Okay.
Okay.
So, IP addresses follow a set of standards known as protocols. Okay. So, these protocols are the backbone of networking. So we learned about two protocols like TCP, IP, and UDP. Okay, so there are various protocols which are used in networking. So these protocols are the backbone of networking and force many devices to communicate in the same language, which is something that will come on to another time. Okay. So, however, we should recall that devices can be on both a private and public network, depending on where they are will okay on where they are will determine what type of IP address they have, public or private. Okay, so like each device has two IP address, like private and public IP address. Okay,
Okay.
yeah. So a public address is used to identify the device or network. Like a public address basically is used to identify device over the internet, and the private address is used to identify a device among other network. Oh, sorry, among other devices within a network. Okay.
Okay. So
Yeah.
actually gives the public addresses?
Yeah. Public addresses are basically provided by internet service provider.
Okay. Does is it like a fixed thing, or is it change? Does it changes?
Which one? Public IP or
Public.
yeah, public IP address are like they basically change according to the internet. Okay,
Okay.
yeah. And the private IP is fixed one, and public IP basically change according to when you switch your network.
Okay.
Yeah. Okay. And like as I told you, like public IP address is provided by internet service provider, and private IP address is provided by DHCP. Okay, we will learn later on. So, okay. So these two devices, okay, there are two devices. So these two devices will be able to use their private IP address to communicate with each other because they are connected to the same network, right? Yeah. So they will
Okay.
communicate with each other through their private IP address. And however, any data sent to the internet from either of these devices will be identified by the same public IP address. So when the devices are into the same network, they will communicate with their private IP. And if the devices are in the same internet, then they will communicate with the public IP. Okay.
Okay.
Yeah. So public IP address are given by the internet service provider, okay, at a monthly fee, okay. Then as more and more devices become connected, it is becoming increasingly harder to get a public address that isn't already in use. For example, Cisco, an industry giant in the world of networking, estimated that there would be approximately 50 billion devices connected on the internet by end of 2021. So enter IP address version. So far, we have only discussed one version of the Internet Protocol addressing scheme known as IPv4, which uses a numbering system of 2 to the power 32 IP address. Okay. So uh, currently, we are using the IPv4 protocol. Okay.
Okay.
Yeah. So the major difference between IPv4 and IPv6 is like IPv4 address consists of four sets of number and which are separated by your dot. Okay, right here. This is IPv4, and each set can range from 0 to 255 just because it has four octets and it can range from 0 to 255. So, however, due to the growing number of connected devices, the available pool of IP addresses is running out. So then we will shift to IPv6. Okay. So IPv6 address was introduced to address the limitation of IPv4 address. So these are 128-bit long. Okay. Uh, and these are written in hexadecimal notation. And these are separated by the semicolon. Okay.
Okay.
Yeah. So the next one is our MAC address. So a MAC address, which is known as Media Access Control Address, is a unique identifier assigned to a network interface card of a device. As we know that each device has its own MIC card, so it is a hardware address and is associated with the physical device rather than the network protocol. So MAC addresses are basically provided by the like manufacturer of the system. Okay.
Okay.
Yeah. So MAC addresses are primarily used in Ethernet networks, and there are like some key points to remember, format, like the MAC address are basically represented as six groups of two hexadecimal digits, with the colon, right? This is the colon and hexadecimal number. Like the first three groups usually represent the organization, or we can say the manufacturer, and the last three groups identify the specific device. Okay.
Okay.
Yeah. So MAC addresses are intended to be globally unique. So each NIC manufacturer is assigned a unique identifier, which is used as the first three groups of the MAC address. Okay. So, however, an interesting thing with MAC address is that they can be faked or spoofed in a process known as spoofing. So this spoofing occurs when a network device pretends to identify as another using its MAC address. Okay. So when the manufacturer provides the MAC address, they provide separate MAC address to different devices, right? There will be no match between two MAC address of the devices. Okay.
Okay.
Yeah. So when this occur, it can often break poorly implemented security designs that assumes that devices talking on a network are trustworthy. So following scenario is like a firewall is configured to allow any communication going to and from the MAC address of the administrator. And if a device were to pretend or spoof this MAC address, the firewall would now think that it is receiving communication from the administration. Okay. So there is a case, I think it is called route table, sorry, ARP spoofing, I think. Yeah. In ARP spoofing, there the MAC address is changed to another's MAC address. For example, like there is a communication going on between two users. So when if the sender asks the receiver to send some important documents, so there the attacker basically changed the sender's MAC address to his own MAC address. Okay, so the important data is sent to attacker rather to the sender. Okay, in this way, MAC address is spoofed.
Okay.
Yeah. So now the practical thing, like the interactive lab stimulates a hotel Wi-Fi network where you have to pay for the service. You will note that the router is not allowing Bob's packet. Okay, we'll go through this later. So what does the term IP stands for?
My internet protocol
Okay, and what is each section of an IP address called?
is octet.
Yeah. So how many sections or digits does an IP address have?
4 or 6.
Yeah. Basically, IP address has four. Okay.
Okay.
Yeah. And what does the term MAC stands for? Then
It's media access control.
yeah. So here, the last one is like deploy the interactive lab using the view shed button and spoof your MAC address to access the site. So right now I told you about ARP spoofing, right? Where the MAC address is spoofed. So here similarly we have to do here, okay, MAC spoofing. Okay, so here you can see here Alice is sending like he is accessing the TryHackMe portal, right? So we
Okay.
are currently Bob. So here it is written that we have to spoof the MAC address and we have to get into the TryHackMe session. Okay. So how we can do, like, when we request this site, like it is going in the into the trash, okay? Like multiple times also we will do, it is going into the trash. So but we have to access this portal. So what we will do is, like, Alice only can access the portal, right? So we will copy this whole MAC address, and then we will paste it here.
Okay.
Yeah. So now the MAC address is spoofed, like it is not actually my MAC address, right? So here I am
Okay.
taking Alice MAC address. And when I will request the site, you can see it is accessing the attractive portal, right?
Okay.
So in this way, the MAC spoofing basically works. So this is the flag we got here. So this is the flag, right?
Okay.
Okay. So now we'll move forward into the ping. Okay, so ping basically is known as packet internet grouper. This is a utility used to test the reachability and latency of a network host. So when we try to, like, reach out to some other system, or we can say IP, so we basically ping that IP address, okay, to check the reachability and latency of the network. So um, Ping basically uses the Internet Control Protocol, message protocol. This is the ICMP. So to determine the performance of a connection between devices. So ping is used to check the reachability, and it uses the ICMP protocol. Okay.
Okay.
So here's how the ping process works. So like when you initiate a ping command, like this is the command for ping. So your device sends an ICMP echo request message to the target host. Okay, it sends ICMP echo host.
Okay.
Okay. Then the target host receives the ICMP echo host message, and then he generates the ICMP echo reply. Okay.
Okay.
Yeah, then once the ICMP echo reply is generated, it is sent back to the device, which means the user, sender. Then your device receives the ICMP echo reply and then calculates the round trip time by subtracting the time the ICMP echo request was sent from. Like it basically subtract the time, when the ICMP echo request was sent and when it came back, the reply came back. It basically subtract that and it gets the round trip time. Okay.
Okay.
Yeah. So the ping command is usually executed from a command from, we can say, terminal using the syntax ping, then the IP address. So ping provides valuable information about the connectivity and responsiveness of a network host, and it can help troubleshoot network issues, assess network latency, and determine if a particular host is reachable or not. Okay. So this is the
Okay.
round time, round trip time, which is calculated by minus subtracting the, like echo request and the echo reply. Okay, so uh, here we are pinging a device that has the private address of 192.168.1.54. Then ping informs us that we have sent six ICMP packets. So here it is telling us six packets transmitted, and all of which we received with the average time of 4.16 seconds. So the average time was 4.16 seconds. Okay, it has been converted. So now you are going to do the same thing to ping the address of 8.8.8 on the deployable website. Okay. So the first question is, what protocol does ping uses?
Yeah, ICMP
Yeah,
protocol.
yeah. So here,
What is the port number of ICMP? Port 22?
yeah, and then here it is written, what is the syntax to ping 10.10.10.10? Okay. So the syntax will be simply ping then the IP address. Okay.
Okay.
Yeah. So the next is, what flag do you get when you ping a.a.? Okay. So we will just go into the view site, and here we have to just ping. So I will write here 8.8.8.8. and then send the ping request. Okay, so this is the Flagra ATHM. I ping the server. So
Okay.
basically, in this command, here it is written ping hyphen c for a.a.8. If you simply write here ping a.8 also, I think it should work. So the meaning of hyphen c is like hyphen c basically specifies the number of packets. Okay, like how much I want to transmit.
Okay.
Here it is written hyphen c4, so I want only four packets to be transmitted. So there are only four packets. Okay.
Okay. Is not obligated to put my C, right?
Yeah. You can simply write ping a.a.8 also.
Okay.
Yeah. So now, okay, this is completed. Okay. And we will move into next one. That is intro
Okay.
to lab.
Okay.
Okay. So here it is written LAN. So local area network. It refers to a computer network that covers a relatively small geographical area, such as a home, office building, school, or campus. So LANs are commonly used to connect devices within a limited area and facilitate local communication, file sharing, and resource sharing. So over the years, there has been experimentation and implementation of various network designs in reference to networking. When we refer to the term topology, uh, we actually refer to a design or look of the network at hand. So let's
Okay.
discuss, yeah. So let's discuss the advantage and disadvantages of these topologies below. So we'll see the topologies which are used. Okay. So basically, topology is the arrangement of a network that comprises nodes and connecting lines through sender and receiver is known as network topology. Okay. Basically, the arrangement of network.
Okay.
Yeah. So first one is like star topology. So in star topology, all the devices are connected to a single hub through a cable. Okay. Like you can see, this is the hub and all are connected to a single hub. So this hub is the central node and all other nodes are connected to the central node, which means that it is centralized network. And the hub can be passive in nature, that is not an intelligent hub such as broadcasting devices. Okay. It can broadcast all the messages. Like it is not intelligent. Like if this device sends the message to he wants to send this message to this system. Okay. So broad hub is not that intelligent that it will directly send it to the particular system only. It basically broadcasts this message. Okay.
Okay.
Yeah. So uh, active hubs have repeaters in them. So coaxial cables or RJ45 cables are used to connect the computers. So your computers are basically connected through coaxial cables or RJ45. And in star topology, many popular Ethernet line protocols are used, such as CD, CSMA. So these are some of the protocols which are used to connect devices. So we will see here what is it is written. So the main premise of a star topology is that devices are individually connected through a central networking device such as switch or hub. And this topology is the most commonly found today because of its reliability and scalability. And its cost is also very much low. Okay.
Okay.
And any information sent to a device in this topology is sent through the central device to which it connects. So let's explore some of the advantages, okay? Because more cabling and purchase of dedicated networking equipment is required for this today, it is more expensive than any of the other topologies. Okay, so there are multiple cables used here, so the cost of cables will be high, right?
Okay.
As only one hub or switch is using, but the number of cables are high, so the price of this will be automatically high. So Furthermore, the star topology is still prone to failure. For example, if the centralized hardware that connects devices fails, like if the hub fails, which means that they will be not be able to send and receive data, right?
Okay.
Yeah. So the only disadvantage of this is like if the hub fails, then there will be no communication between these devices. So we will move into the burst topology. So bus topology is a network type in which every computer and network device is connected to a single cable. So as you can see, only a single cable is used. So it is a bidirectional, which means like from the both the direction we can send or receive data. Okay. So it is a multi-point connection and a non-robust topology because if the backbone fails, the topology crashes. So if this cable crashes, the whole topology will be crashed. Okay.
Okay.
Yeah. So in bus topology, various MAC protocols are followed by LAN, such as CDMA and slotted alpha, etc. Okay. So advantages of bus topology are like if n devices are connected to each other in a bus topology, then the number of cables required to connect them is one. Like here we have to connect like if there are n numbers of systems, then we want n numbers of cables to connect them. But here only we want one cable, right?
Okay.
And this cable is known as backbone cable. Okay. So coaxial or twisted pair cables are mainly used in bus. Okay, bus topology. And the cost of the cable is less compared to other topologies, but it is used to build small networks. Okay.
Okay.
Yeah, and some of the drawbacks of like bus topology are a bus topology is quite simpler, but still it requires a lot of cabling. Okay,
Okay.
yeah, and if the common cable fails, then the whole system will crash down. Okay, and here the security is very low, and adding new devices to this network would slow down the network. So, the common example of bus topology is Ethernet LAN, which where all devices are connected to a single coaxial cable. Okay, and then
Okay.
the next one is ring topology. So, in ring topology, it forms a ring connecting devices with exactly two neighboring devices. So there are exactly two neighboring devices for each of the system, and a number of repeaters are used for ring topology with a large number of nodes because if someone wants to send some data to the last node in the ring topology with 100 nodes, then the data will have to pass through the 99 nodes to reach the like if there are 100 system connected, then if here the first one wants to send the message to the last one, then like it has to pass through the all 99 systems, right? So hence, to prevent data loss, the repeaters are used in the network. Okay.
Okay.
Yeah. So the data here flows only in the one direction. That is, it is unidirectional. Okay. But it can be made as bidirectional by having two connection between each network node. So it is called like when we connect two connections between each network node, it is called dual ring topology. So in ring topology, the basically like token passing and basically it accesses two common methods, token passing and token. So, in token passing, it is a network access method in which a token is passed from one node to another for the communication. But in the token, whereas token is a frame that circulates around the network. And if I want to like simply connect to or communicate with any of the system connected in the ring topology, I will make use of the repeater to connect to that particular device. Okay.
Okay.
Yeah. So here the in ring topology, the devices are basically um, the data is transmitted basically in the high speed. Okay.
Okay.
Yeah. So now the next one is switch. So switches are basically dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, or any other networking. So, switch is a network device that is used to segment the networks into different subnetworks. Right here, you can see here one network is like broken or distributed into subnetworks, right, with the help of switch.
Okay.
Yeah, so it is responsible for filtering and forwarding the packets between LAN segments. So switches have many ports, and when data receives at like arrives at any port, the destination address is examined first, and then some checks are also done. So like features of like network switches are like it basically operates in the data link layer of the OSI model, and both switches and routers can be connected to one another. As I told you, that switch is multiple port device, so it can connect multiple devices. And to connect to internet, we make use of the router. Okay,
Okay.
yeah. So what is a router? So router's job is to connect networks and pass data between them. So here, within the internet and switch, the router is working as a transmitter. Okay,
Okay.
yeah. So routing is the label given to the process of the data traveling across the network. So this is the label given, and routing involves creating a path between networks so that this data can be successfully delivered. Okay, and routing is useful when devices are connected by many paths. So basically, routing find out the best and the shortcut paths to transfer the data. Okay, like here,
Okay.
it can simply in this figure, like if computer A wants to communicate with computer B, then it has to like go through this switch, then this switch, then this switch. But directly it can connect here. Okay, right through the two switches. So rather than going through three switches, it can directly go through the two switches. Okay,
Okay.
yeah. And now the practical one, like what does LAN stand for?
Local area network.
Yeah, so it is local area network. And what is the verb given to the job that routers perform?
Routing. It does routing.
Yeah, the process is known as routing, okay, which the router performs, right? So here it is written, what device is used to centrally connect multiple devices on a local network and then transmit it to the correct location. So here we learned like to connect multiple devices, it is used switch, okay?
Okay.
Yeah, and it's written what topology is cost efficient to set up. So bus was the most cost efficient one because it only needs single cable, right?
Yes.
Yeah, and what topology is expensive to set up and maintain? So star topology, because in the star topology we saw like multiple cables are used, and it might take a multiple amount, and it will, and security is also low, right?
Okay.
Yeah, so here complete the interactive lab attached to this task. What is the flag given at the end? Okay, we'll go through this. So yeah, so this lab will take you through the flaws in different network topologies. Okay, the next ring topology. In a ring topology, all devices are connected to others to create a full circle. Okay, then packets of data travel from one device to the next until they have reached the destination.
Okay.
And one of the major flaws with the ring topology is that if a device goes down or a cable is broken, then data will be no longer be passed, right? Because if one cable is broken, the data will be stopped there only. So if you have hover over the middle of the network cable, you can cut it and see what happens to the packets. So let's cut this. So you can see here on the uh, packet transferring has been like stopped, right? Because it is not transferring only here because of this cable.
Okay.
Then the packets can now no longer travel around the network and no devices can talk to each other. And the next one is bus topology. So with a bus topology, all devices are connected to a single cable, often called the backbone cable. And data is sent in both left and right directions down the backbone until the packet's destination is reached. Okay.
Okay.
Then a major flaw in the bus topology is that it can't handle a large amount of data. Yeah, we learned here like adding a new device takes like slows down the performance, right?
Okay.
So that's similar. Then on the next step, send as many packets as quickly as you can try to take down the network. So we have to take down the network. So what do you think from which computer to which computer we have to send the packets so that the network slows down?
From two to like four.
Okay, let's see, like 2 to 4 you said, right? No? Okay, we just try send packet. You can see from this second one, it is going with network. Yeah, okay. So the burst network is now down. Okay,
Okay.
yeah. So now star topology. With a star topology, all devices are connected with their own cable to a central switch or hub. Every packet is sent through this switch, which means if the switch goes down, the network will no longer work. So see if you can somehow break the switch. So we have to just break the switch. Okay. So we'll just break
Okay.
this. Yeah. The network is now slow down. Okay. So we found the like flag. Yeah, this is the flag. Okay. So now we'll move forward with the primer on subnetting. Yeah. So as we previously discussed throughout the module so far, networks can be founded in um, all shapes and size, ranging from small to large. So subnetting is a term given to split up a network into smaller. Okay.
Okay.
Yeah. So when a bigger network is divided into smaller network to maintain security, and that term is known as subnetting. So think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everyone wants a piece. So subnetting is you deciding who gets what slice and reversing such a slice of its metaphorical cake cookie. So take a business, for example, you will have different departments such as accounting, finance, and human resource. So Milish, you know where to send information in real life to correct department. Networks need to know as well. Network administrators use subnetting to categorize and assign specific parts of a network to reflect this. Like the basic work of subnetting is that if for example, if there in an organization there are 50 computers, okay. So if we will assign the public IP, or we can say yeah, public and private IP to these devices. Like we will if we will offer different IP address, okay, for each devices we will apply different IP address. So it would be like it would generate more cost like, as asking to the ISP, like internet service provider, for 50 IP addresses. It would cost a high amount of money, right?
Okay.
So instead of asking 50 different IP address, what here we can do is like only ask one IP address and then submit that IP address to 50 devices. So here with the example, let me just tell you. For example, this is a computer, right? Okay, this one, this is a computer. You just imagine, and we have asked to the internet an IP address. So this computer has assigned an IP address, and now this IP address, like it ranges from 0 to 25, right? 255.
Okay.
Yeah. So it will just divide that IP address to these computers. Okay.
Okay.
Yeah. So basically, subnetting works like that. So subnetting is achieved by splitting up the numbers of hosts that can fit within the network. For example, you just take like this is the IP address we got 192.168.1.1. So like in this octet 4, the range is from 0 to 255. So we will assign like for the first computer we will assign 192.168.1.2, and for the third one 1.3, then fourth one 1.4. In this way we can just assign a multiple IP from a single IP. Okay.
Okay.
Yeah. So as we can recall, an IP address is made up of four sections called octets. The same goes for a subnet mask, which is also represented as a number of 4 bits, sorry, bytes, ranging from 0 to 255. So subnet uses IP address in three different ways, like identifying the network address, then identifying the host address, and identifying the default gateway. So here we will see about network address, like what basically network address means. So network address is basically is a unique, or we can say logical address that distinguish a network node or device over a computer or telecommunication network. So this address identifies the start of the actual network. Okay.
Okay.
Yeah. And the host address, an IP address here is used to identify a device. So to identify a device, host address is used. Like
Okay.
here it is an explanation is given. Like for example, a device with the IP address 192.168.1.100 will be on the network identified by this. So in the host address, our device will have the network address of, yeah, as I told you now, like we have to subnet the single IP address into multiple. Same process is done. And in the default gateway address is a special address assigned to a device on the network that is capable of sending information to another network. So basically, what is the work of gateway? So gateway is used to transmit data between two different networks. Okay,
Okay.
so here it is done in the similar way only. And now, in small networks, such as at home, you will be on one subnet as there is unlikely chance that you need more than 254 devices connected at one time. So, however, places such as business and office will have much more of these devices like PCs, printers, cameras, and sensors, where subnetting can take place. Yeah. So, subnetting provides a range of benefits like efficiency, security, and full control. So, efficiency, like a single IP address is divided, so there is more efficiency in that, and we can have the full control over all 50 devices, right?
Okay.
Yeah. So we will come on to explore exactly how subnetting provides these benefits at a later date. However, for now, all we need to understand. Okay. So now, what is the technical term for dividing a network up into smaller pieces?
Subnetting.
Okay. So how many bits are there in a subnet mask? Here only we learned here the same goes for the subnet marks that it has 32 bits. Okay,
Okay.
yeah. And then what is the range of the section of each octet? So it was 0 to 255. And what address is used to identify the start of a network? So it was network address from the start of the actual network, right?
Okay.
And which address is used to identify device within the network? So it was host address.
Okay.
And here device name used to identify the device responsible for sending data to another network. So to transmit data to different networks, it was used default gateway. Okay,
Okay.
yeah. So the next one is the ERP protocol. So recalling from our previous task, that devices can have two identifiers, a MAC address and a IP address. So the ARP protocol, or we can say address resolution protocol for short, is the technology that is responsible for allowing devices to identify themselves over a network. Okay. So ARP, like most computer programs uses IP addresses to send or receive messages. So, however, the actual communication happens over physical address, that is MAC address. Okay. So,
Okay.
our mission is to get the destination MAC address, which helps to communicate with other devices. So this is where ARP comes into the picture. Like its functionality is to translate IP address to physical address. Like the work of ARP is to convert IP address to MAC address. Okay.
Okay.
Yeah. So ARP basically finds the hardware address known as MAC address. So MAC address is used, sorry, ARP uses MAC address to identify the devices over a network. Okay.
Okay.
Yeah. So now how does ARP work? So we'll see this. Each device within a network has a ledger to store information on, which is called a cache. So in this context of the ARP protocol, this cache stores the identifiers of the other devices on the network. So basically, ARP stores the MAC address of the devices as unique cache.
This protocol stores MAC address or something.
Yeah, it basically stores MAC address.
Yeah.
So ARP maintains a ARP table. Okay, ARP protocol maintains an ARP table where it stores MAC address of each devices where it connects to a new device. Okay,
Okay.
yeah. So in order to map these two identifiers, like IP address and MAC address, the ARP protocol sends two type of message. So imagine a device that wants to communicate with others over the internet. So what does ARP do right now? So it broadcasts a packet to all the devices of the source network. Okay. So the devices of the network, they peel to a header of the data link layer from the protocol data unit called frame, and then they transfer the packets to a validated IP address. So where, for example, you just listen, like in a network the one device it sends like I want to communicate to this network. Okay, it sends this message to ARP. Okay, so
Okay.
then ARP will do like ARP will broadcast the message to every devices which are connected. Like this IP address is of which device?
Okay.
Yeah. So like uh, uh yeah. So that this process continues till the second last network device in the path reaches the destination. When this message reaches the destination, where it gets validated and ARP in turn responds with the destination MAC address. Okay, like when the targeted system replies that I am the system uh, which you were asking. Okay, so when ARP gets the MAC address of the targeted system, so he then sends the ARP reply to uh, the system which was like first which was used. Okay,
Okay.
yeah. So here basically in the ARP request, so ARP request is nothing but broadcasting a packet over the network to validate whether we came across the destination MAC address or not. Okay.
Okay.
Here, it basically like sends the physical address of the sender, then IP address of the sender, then physical address of the receiver, and the IP address of the receiver. Okay, in the request packet.
Is it like a
And
TCP connection or something?
yeah, but in TCP connection, it needs like acknowledgement also, right? Acknowledgement. But
Okay.
in the ARP packet, basically, first of all, it only sends the request, and then in return the targeted system replies. Okay, yeah, basically we can say it is similar to TCP only.
Okay.
Then the next one is ARP reply. So okay, so it is the MAC address response that the source receivers, or we can say the source receives from the destination. Okay,
Okay.
yeah. So what does the ARP stands for?
Address resolution protocol.
Yeah. So what category of ARP packets ask a device whether or not it has a specific IP address? So like which protocol basically asks like this IP address is
This
a specific
first
IP address.
send request.
Yeah. And then what address is used as a physical identifier for each devices?
Oh, that's MAC address.
Yeah. And the logical identifier is IP address. Okay.
Normally, which is used for physical address or the logical address?
For what?
Like to identify a device, like does it use physical address or like logical address? Do you need MAC address or like IP address?
IP address.
Right.
Yeah. So now the next one is our DHCP protocol. So DHCP stands for Dynamic Host Configuration Protocol, and it is the critical feature on which the users or of an organization communicate with each other. Okay. So DHCP helps organizations to smoothly manage the allocation of IP address to the end
No.
users. Okay. So like when a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request. So here, what it basically does is like, let me just tell you. Um, as I told you, like DHCP basically provides IP address.
Okay.
Yeah, it provides private IP address. Okay. So here, what basically it does, like when a new device is like recognized, then the new device will like ask to DHCP like, hey, I'm the new here, and is there anyone who can give me an IP address? Okay.
Okay.
And then here, the DHCP server, he offers a he offers simply random IP address to the this system. Okay.
Okay.
Like make sure thing you can have this IP address. And if this system he manages like yeah this IP address is okay for me, then he will say that to the uh, DHCP like yes that would be brilliant. I start using this IP address. Okay, and then after that DHCP will acknowledge that okay great you can just use that IP address. So in this way, the DHCP works. So this process is known as DORA. Okay, like discover, offer, request, and acknowledgement. So this process is known as DORA.
Okay.
Okay. And so we'll move into the question like what type of DHCP packet is used by a device to retrieve an IP address? Like to which packet is basically used by the device to identify or discover any of the IP address. So here we learn DHCP discover basically does that.
Um, could you explain this one?
Here it is asking that like what type of DHCP packet is used by a device to retrieve an IP address, which means like to get IP address.
Okay.
So it here we learn that DHCP discover is the packet which is used by the unknown device or new device to get new IP address, right?
Okay.
Yeah, so it was DHCP discover. Then what type of DHCP packet does a device send once it has been offered an IP address by the DHCP server? Like when the
Oh,
DHCP,
you send a request.
yeah. Then finally, what is the last DHCP packet that is sent to a device from a DHCP server?
It's acknowledgement.
Yeah. And then, okay. So we'll just take 5 minutes break and after that we will continue to the next topic, okay?
Okay, sure.
Yeah. Okay, hello.
Hello.
Yeah. So our another topic is OSI model. Okay.
Okay.
So okay. So the OSI model, known as Open System Interconnection Model, this is a conceptual framework that standardizes the functions of communication system into seven different layers. It helps in understanding and describing how different network protocols and technologies work together to enable communication between devices in a network. So each layer of the OSI model has specific responsibilities and they interact with the layers above and below it. Okay. So
Okay.
like OSI model has been developed by ISO, International Organization for Standardization, in the year 1984. Okay. So the seven layers are like application, presentation, session, transport, network, data link layer, and physical layer. So let me just explain one by one. Acha, it is given. Afterwards, we will go through it. Okay.
Okay.
Yeah. So what does OSI model stands for? So it was open.
Open system interconnection model.
Yeah. So open system interconnection. Yeah. So in how many layers OSI model have?
Seven.
Yeah, it has seven layers. So what is the key term for when pieces of information get added to the data? Uh, what's the question? What is the term, key term for when pieces of information get added to the data? Okay. So it is called encapsulation, I think.
Okay.
Let's see. Yeah, it's encapsulation, right?
Okay.
Okay. So we will go through the seventh layer, that is application layer. So application layer, at the very top of the OSI reference model, we find the application layer. Okay, so which is implemented by network applications. So these applications provide the data which has to be transferred over the network, and this layer also serves as the window for the application servers services to access the network. So here the real uh, use of applications are done, such as email clients, browsers, or file server browsing software. So here, this layer basically uses various protocols and rules to determine how the user should interact with data sent or received. Okay, so here the
Okay.
actual use of applications are done. So what is the name of this layer? So it is application.
Application.
Yeah, application. And what is the term that is given to the name of the software that users interact with? So users interact like the most normal term is like basically in every system the users interact with the graphical user interface, right?
Okay.
Yeah. So the answer will be graphical user interface. Yeah, okay. Okay. So the next one is presentation layer. So the presentation layer is also known as the translation layer, and the data from the application layer is extracted here and then it is manipulated as per the required format to the transmitted over the network. Right here, encryption, decryption is done, and then compression is done. Okay, which means like when the data is received from the application layer, then here the data is like modified according to the required format. Okay, like for example, if
So
it
here
in
encryption, decryption is done.
yeah, encryption, decryption is done, and then compression is also done. Like it is reduced. The number of bits are reduced. Okay, so that it can be further transmitted.
Okay.
Yeah. So we will just read once again. Like layer 6 of the OSI model is the layer in which standardization starts to take place because software developers can develop any software such as email client differently. The data still needs to be handled in the same way, no matter how the software works. So this layer acts as a translator for the data. As I told you, like after receiving the data from the application layer, it basically changed the format, right?
Okay.
Yeah. So security features such as data encryption occur at this layer. Okay. So what is the name of this layer?
Presentation.
Yeah, presentation. And what is the main purpose that this layer acts as?
Translating.
Yeah, so it will be translator, right? Okay. So next one is our session layer. So yeah. So this layer is responsible for the establishment of connection and like maintaining the sessions and authentication of users according to the security. Okay.
Okay.
Yeah. So here we'll see once data has been correctly translated or formatted from the presentation layer, the session layer will begin to create a connection to the other computer. As I told you, like it establishes a connection, right?
Okay.
Yeah. So when a connection is established, a session is created within the connection. So this connection is active, so this is the session. So when the connection is established, then after establishment of connection, then the maintenance of session is done. Okay.
Okay.
Okay. So the session layer synchronizes the two computers to ensure that they are on the same page before data is sent and received. So basically, synchronization means like this layer allows a process to add checkpoints that consist. We can say like synchronization is like identification of the same network. Okay.
Okay.
Yeah, so that the data loss is not occurring. Okay, like if the devices are in the different layers and we don't know what are the protocols we are going to use, so we need to synchronize those two computers in the same network. Okay, so that data
Okay.
will be easily sent. So once these checks are in place, the session layer will begin to divide up the data into smaller chunks of data and begin to send these chunks, which are known as packets, one at a time. So this dividing up is beneficial because if the connection is lost, only the chunks that weren't yet sent will have to send again. Okay. So here the data are broken up into the small packets, and these packets are like different numbers are given to these packets. Okay, like if there are 10 packets, then 10 packets will be numbers will be assigned. And here there is no need that uh, the packets must go into the serial wise. They go in the random way. Okay. So if the connection is lost, like if five packets went and five packets are left, so there is no need to send the again the five packets. We can say 10 packets from the beginning. We have to only send the remaining packets which have been left. Okay.
Okay.
Yeah. So we will see what is the name of this layer.
Session.
Yeah. So what is the technical term for when a connection is successful established? Hello?
Um.
Yeah. So here it is
um,
written like when a connection is established, session is created, right?
Okay.
Yeah. So it will be session. Okay. And what is the technical term for small chunks of data?
A technical term from small chunks of data packets.
Yeah, is packet. Okay. Now the fourth layer is transport layer.
Okay.
Yeah. So the transport layer provides services to the application layer and then takes services from the network layer. Okay.
Okay.
And the data in the transport layer is referred to as the segment. In the session layer, data was broken into smaller chunks and they were known as packets. And here in the transport layer, the data which are transferred
Data
are in the
transporter.
yeah segments. So it is responsible for the end-to-end delivery of the complete message. Okay, transport
Okay.
layer. And the transport layer also provides the acknowledgement of the successful data transmission.
Okay.
Yeah. So um, here is written like it follows one of the two different protocols that are decided based upon several factors, TCP and UDP. So TCP. So we can say TCP. Yeah. So TCP, which is known as Transmission Control Protocol. This basically potentially hindered by the name. This protocol is designed with reliability and guarantee in mind. That protocol serves a constant connection. So the main difference between TCP and UDP protocol is like that TCP is connection oriented and UDP is connectionless protocol. Okay, which means like connection oriented is like when like um, yeah, I remember. In the TCP packet, we know that there are three types of packets which are sent. Okay, like SYN and SYNACT and acknowledgement. Okay.
Okay.
Yeah. So, why we say TCP is connection oriented because in TCP, when the SYN packet is sent from the sender side, then the receiver provides the acknowledgement packet like yes, the connection has been established. Okay. And when the connection is established, after establishment of connection, the communication is done. Okay.
Okay.
But in the UDP protocol, there is no need to have connection establishment. Without the establishment of connection, the communication is done, whether the receiver receives the message or not. Okay.
Okay.
Yeah. So we will see, like, let's summarize. Like, advantages of TCP is like this guarantees the accuracy of data, and this is capable of synchronizing two devices to prevent each other from being okay. Then performs a lot of processing from reliability, and the disadvantage will be like that it is slower because uh, they're getting the SYN packet and then the acknowledgement packet. The process is longer. Okay, so therefore it is slower than UDP. Okay.
Okay.
Yeah, so this slow connection can bottleneck another devices as the connection will be reserved. So when one system is communication with other, so another system cannot like re-establish new communication. So therefore, it is bottleneck because connection is reserved. Okay.
Okay.
Yeah. So it in the first method written that requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. Okay. So in the session layer, we saw that uh, when the 10 packets were being transmitted, if the connection was lost, then afterwards we can send the remaining 5 packets. But here it is different. Here it is that like if one small part of the data is lost, then the remaining data is of no use. Okay.
Okay.
Yeah. So TCP is used for situations such as file sharing, internet browsing, or sending an email. So this usage is because these services require the data to be accurate and complete. Okay. So the diagram below, we can see how a picture of dog is broken into small pieces of data. So here the in the TCP protocol, the single photo is divided into different packets and then it is sent. If you imagine packet one is lost, then it is is there any use of packet two and packet three?
Packet 2 and packet 3.
Because if packet one is lost, there will be no use of packet one and packet three. Like if there is a message, like in packet one, it is written like I am this, and in packet two, it is written like from this organization, and packet three is the original message, right? So if
Okay.
packet three is lost and packet one and packet two is only received to the this computer, then this computer will able to know the actual message or not.
Okay.
Yeah, he will be not be able to get the message, right?
Okay.
Therefore, if one packet is lost in the TCP protocol, then there is no use of the remaining packets. Okay.
Okay.
Yeah. So now let's move on to the user datagram protocol, that is UDP. So this protocol is not nearly as advanced as its brother, the TCP protocol. So it doesn't boost the many features offered by TCP, such as error checking and reliability. So TCP also has the features such as error checking and reliability, and this UDP lacks this feature. Okay.
Okay.
Yeah. So in fact, any data that gets sent through UDP is sent to the computer, whether it gets there or not. As I told you, whether it reaches the receiver or not doesn't matter. Okay.
Okay.
Yeah. So advantages of UDP is that UDP is much faster than TCP because there is no need of acknowledgement packet, and UDP leaves the application layer to decide if there is any control over the how quickly packets are sent. So basically, packets are sent in which speed. It basically that matters. Okay. And UDP does not reserve a continuous connection on a TCP or on a device as TCP connection. Okay, there is no reserved connection. We saw now, like in TCP, there was a reserved connection for each session.
Okay.
Yeah, but in UDP, there is no reserved connection. So any device can communicate with any other device according to its requirement. Okay.
Okay.
And the disadvantage is like UDP doesn't care if the data is received or not. Okay, then it is quite flexible to software developers in this sense, and this means that unstable connections result in terrible experience for the user. So here we learned how the terrible experience is that okay, like packet one is lost, then packet this is the result, and we cannot recognize what is the photo. Okay,
Okay.
yeah. So now we will just move into the question. What is the name of this layer?
Transport.
Yeah, it was transport. And what does TCP stand for?
Uh, Transport Control Protocol.
It was transmission control protocol. Okay.
Transmission Control Protocol.
Yeah. So it was transmission control protocol. And then what does UDP stands for?
Um,
It is user datagram.
User Datagram Protocol.
Yeah. Then what protocol guarantees the accuracy of data?
TCP.
Yeah, TCP. Then what protocol doesn't care if data is received or not by the other device?
UDP.
Yeah. And what protocol would an application such as an email client use?
TCP.
Yeah. Then what protocol would an application that downloads file use?
TCP.
Okay. Then what protocol would an application that streams video use?
UDP.
Okay, right. So next one is our network. This is layer third. So the network layer works for the transmission of data from one host to other located in different devices. Okay, sorry, different networks. Like it also takes care of the packet routing, that is selection of the shortest path. I told you in the previous example of with the photo, like The shortest path one. So the sender and receiver's IP addresses are placed in the header of the network layer. So the third layer of the OSI model is network layer. This is the magic of routing and reassembly of data takes place. Firstly, routing simply determines the most optional path in which these chunks of data should be sent. Like basically, a network layer uh, chooses the best, shortest path for transmission. Okay.
Okay. What
Then
does it actually do, network layer?
network layer basically determines the shortest path for data transmission.
Shortest. Okay.
Okay. Then some protocols at this layer determines exactly what is the optimal path that should data should take to reach a device. We should only know about their existence at this stage of networking module. Briefly, these protocols include OSPF, like this is the open shortest path first, and RIP, routing information protocol. So the factors that decide what route is okay. So in what basis the like network layer decides the route? Okay, route. So the first one is what path is the shortest. So first of all, it will check for the shortest path. Okay,
Okay.
and then the second one, like what path is the most reliable one? Like that is have packets been lost on that path before. So it will see like which path is the more reliable one and which is the most easier one. Okay,
Okay.
and then which path has the faster physical connection. Yeah, like copper connection will be slower and fiber will be considerably faster. Okay.
Okay.
Yeah. So at this layer, everything is dealt with IP address such as this. So devices such as routers capable of delivering packets using IP address are known as third layer devices. So routers come under the third layer devices. Okay.
Okay.
So the first question is, what is the name of this layer?
A network?
Yeah. So will packets take the most optimal route across a network?
Yes.
Okay. And what does the acronym of OSPF stand for? So it was here, right? Open shortest path first. Then RIP's acronym, that is Routing Information Protocol. And what type of address are dealt with at this layer?
IP address.
Okay. So IP, yeah. So the layer second is data link layer. So uh, the data link layer is responsible for the node-to-node delivery of the message. The main function of this layer is to make sure that data transfer is error-free from one node to another. Okay.
Okay.
When a packet arrives in a network, it is the responsibility of the data link layer to transmit it to the host using its MAC address. Here, the MAC address is used. In the network layer, its IP address was used, and in the data link layer, the MAC address is used. Okay.
Both are used to find the root or something?
Yeah.
Okay.
Then the functions of data link layer are like framing. So framing is the function of the data link layer. It provides a way for the sender to transmit a set of bits that are meaningful to the receiver. So it provides a better way, like framing basically provides a better way. Okay. So
Okay.
yeah, and the second one was like error control. So the data link layer provides the mechanism of error control in which it detects and then retransmits damaged or lost streams. So when like any error is occurred and some sort of like packets are lost, it will detect and then it will try to retransmit those lost packets to the receiver. Okay,
Okay.
and then flow control. So the data rate must be constant on both sides, else the data might get corrupted. So flow control coordinates the amount of data that can be sent. For example, like if the sender has the capability of sending 50 KB of data, right? And if
Okay.
the receiver does not have the like ability to receive 50 KB of data, so here what he will do, like he will ask the sender to like minimize the data, sorry, minimize the yeah ability of data, like reduce it to 25 KB or something, right? So
Okay.
flow control basically means that there must be constant like constant ability of sending data on both the sides. So the first question is, what is the name of the layer?
Oh, data link layer.
Okay. So what is the name of the piece of hardware that all network devices come with?
Devices.
As I told you in the like I think previous topic, like all every hardware has the NIC card, right? Which connects
Oh,
to
yeah,
network.
yes.
Yeah. So it will be network interface card. Okay.
Okay. But the NID card contains the MAC address.
Yeah. Yeah. It contains the MAC address.
Okay.
And the first layer is the physical layer. So the first layer is the physical layer. It is responsible for the actual physical connection between the devices, right? So
Okay.
the physical layer contains information in the forms of bits, and it is responsible for transmitting individual bits from one node to the another.
Okay.
When receiving data, this layer will get the signal received and it converts the signal into zeros and one, and then it sends the zeros and one signal into to this data link layer. Okay, so yeah, bit by bit
Okay.
transfer is done. Okay,
Okay.
yeah. So we will see so here Ethernet cables are used to connect the devices, right?
Okay.
Yeah. So we'll just go into the question like what is the name of the layer? So this is physical layer.
Physical.
Yeah. And what is the name of the numbering system that is both zeros and one?
A binary.
Yeah, binary. And what is the name of the cable that are used to connect devices?
Ethernet cables.
Yeah, Ethernet cables. Okay, great. So now practical game is there. So will you try this one or now only will do?
Sorry, couldn't hear.
I said like, will you try by it your own or now only will do this practical?
Okay, we can do. No problem.
Okay, you just try once, okay?
Okay.
Yeah. So our next topic will be packets and frames, okay?
Okay.
Okay. So what are packets and frames? So yeah, so packets and frames are a small piece of data uh, that when forming together makes a larger piece of information or message. So however, these they are two different things in the OSI model. A frame is at the layer 2, that is data link layer, which means that there is no such information as IP address. And here, think of this as putting an envelope within an envelope. And acha, frame is basically nothing like it does not contain any of the information. It is just similar like putting an envelope inside another envelope. Okay,
Okay.
yeah, and the process is called encapsulation. So this process is called encapsulation. And at this stage, it's safe to assume that when we are talking about anything IP address, we are taking or talking about packets. Okay. So when we talk about the packets, which means like we are talking about the IP address. Okay. So when
Okay.
the encapsulating information is stripped away, we are taking about the frame itself. Okay, talking about the frame itself. Okay. So Packets are an efficient way of communicating data across network devices, such as those explained in task 1, because this data is exchanged in small pieces and there is less chance of bottlenecking occurring across our network than large message because being sent. Okay, so why we send the message in the form of packets? So we send the message in the form of packets so that there is no case of bottlenecking, right?
Okay.
Yeah. So for example, okay, this is the same example, and packets have different structures that are dependent upon the type of packet that is being sent. As well, we will come to discuss networking is full of standards and protocols that act as set of rules for how the packet is handled on a device. With the internet predicted to have approximately 50 billion devices connected by the end of the 2020, things quickly get out of the hand if there is no standardization. So let's consider with our example of the internet protocol. So, like there are some of the headers like okay, like time to lift. So this is the time taken to like send the packet. Okay,
Okay.
yeah, and then this is the expiry time basically, and then the checksum. So this provides integrity checking for protocols such as TCP. If acha, checksum basically checks the integrity of the data. Okay,
Okay.
and the source address is the IP address of the source, which means the sender, and destination address is the IP address of the receiver. Okay,
Okay.
yeah. So, what is the name for a piece of data when it does have IP addressing information?
The name. Okay. So when data packets.
Yeah, so it will be packets because when we talk about IP address, this means like we are talking about the packets only. Okay, just it's
Okay.
yeah. And then what is the name for a piece of data when it does not have IP addressing format? So it will,
Frames.
yeah, frames. Okay. And then the first comes the TCP, the three-way handshake, which was I was telling you right now, SYN, and acknowledgement. So the
Okay.
three-way handshake basically is the SYN, and acknowledgement. Okay. So let's first of all
Okay.
read this. So TCP or Transmission Control Protocol for short is another one of these tools used in networking. This protocol is very similar to the OSI model that we have previously discussed in the room 3 of this module so far. The TCP/IP protocol consists of 4 layers and is arguably just a summarized version of the OSI model. These layers are application, transport, network, and internet and network interface. Okay,
Okay.
so very similar to how the OSI model works. Information is added to each layer of the TCP model as the piece of data or packet traverses it. So, as you may recall, this process is known as encapsulation, right?
Okay.
Where the reverse of the process, acha, and the reverse process is known as decapsulation. So,
Okay.
one defining feature of TCP is that it is connection based. As I told you, it is connection oriented, right? Yeah. So which means that TCP must establish a connection between both a client and device acting as a server before data is sent. Okay. So before communicating, it needs to establish a connection between client and the device. Okay.
Okay.
Yeah. And then we have seen the advantages of and disadvantages of TCP, right? So in the TCP packet, this contains various information such as this source port, which is the source port of port of the sender, right?
Okay.
through which port the communication will be done, and the destination port, which means that which port is opened at the end of receiver, and then source IP is the IP address of the sender, and then destination IP is the IP address of the receiver. Then sequence number, which means like I told you now, like uh, for example, if a message is broken up into 10 packets, and then those 10 packets are numbered, right,
Okay.
from 1 to 10, they give the random number. So sequence number basically is that only, like numbering the packets, okay?
Okay.
And acknowledgement number, like after a piece of data has, acha. So acknowledgement number basically, uh, a new piece of data is added with the actual data when it is returned, okay?
Okay.
Yeah. And checksum, as I told you, it basically checks the integrity, and data is the actual message which is being transmitted or stored, and flag. So this header determines how the packet should be handled by either device during the handshake process. So specific flags will determine specific behaviors, which is okay. So flags basically determine the behavior of the process, okay, during the handshake process.
Okay.
Yeah. So we will come to the three-way handshake. So there are like these are the messages. So in the three-way handshake, the basically these three comes in the three-way handshake, and these are the additional one. So SYN basically, this is the initial packet sent by the user, okay, which means the sender,
Okay.
to initialize a connection, okay. And SYNAC packet, this is the packet. This packet is sent by the receiving device to acknowledge and synchronize. Okay, so SYNAC packet is basically sent by the receiver to acknowledge the synchronization process. Okay,
Okay.
and the acknowledgement packet is either it can be either be sent by the sender also and receiver also. Like, yes, we are now ready to establish a connection. So acknowledgement packet basically carries this. Okay,
Okay.
and data basically this is the actual message, and fin packet, like this packet is used to cleanly close the connection, like finish the packet, finish the communication, right?
Okay.
And RST packet, basically this is the packet to reset the packets. Like if the packet ends all the communication, like some of the packets are lost. So this indicates that some error has been occurred. So we need to reset the process. So this uh, packet basically resets all the process. Okay.
Okay.
Yeah. So the diagram shows below shows a normal three-way handshake process between Alice and Bob. In real life, this would have been between two devices. This is the example, right? Like Alice sends like, I want to build a connection with Bob. Then Bob sends, yeah, we can make surely we make a connection. Then Alice sends, yeah. So our now connection is established. So in this way, communication is started with the help of the three-way handshake. Okay.
Okay.
Yeah. So, okay. So any sent data is given a random number sequence and is reconstructed using this number sequence and incrementing by one. So when the data are sent from the senders and they are sent in the scramble way, right? So when they reach at the receiver end, the receiver reconstruct it according to the sequence number. Okay.
Okay.
Then incrementing by one. Okay. So both computers must agree on the same number sequence for the data. So, like SYN packet is here is the initial sequence number to synchronize with zero. Then SYNAC server initially synchronize. Okay, so yeah, what does this basically mean? Like the client initial number is zero, then the final number will be zero plus one. Here the incrementing is zero by one. Okay,
Okay.
and when the initial number of the packet is 1, then again it will add one increment, it will increment it by 1. Okay, so in
Okay.
this way incrementation is done. So when TCP want to close the connection, Like Alice will ask the Bob, like, I want to finish the connection. Okay. So Bob will say, yes, I do want to finish the connection. So in the acknowledgement packet, he will write this and he will send the finished packet also. And after that, Alice will again send like, yeah, so our connection has been successfully completed. Okay.
Okay.
In this way, the TCP connection is closed. So we will just move into the question like, what is the header in a TCP packet that ensures the integrity of the data? So we,
Checksum.
yeah, it is checksum and provide the order of the normal three-way handshake protocol. Okay,
Synac.
yeah, it will be SYN, then just a second, then SYNAC, and then ACK, right?
Yes.
Yeah. So we will just do one practical. Okay. So help Alice and Bob communicate by reassembling the TCP handshake in the correct order in the static lab attached to this task. Enter the value of the flag given at the end. Okay. So we'll see what's the question here. Like Alice is asking, Sin, can you hear me, Bob? And finish goodbye. And okay. So what here? Okay, we need to help them to communicate. Okay. So I will just write here Sin. Okay. Then after Sin, he will say, Sin, yes, I can hear you, right? Then
Okay.
after that, okay, great. Uh, okay, I can hear you. I'm all done. Received. Acha, that is incorrect answer. Um, acha, okay. So yeah, what it has been basically done, like we will do it once again. Wait, let me just tell you. Like first of all, here it is asked us to communicate between. We have to help communicate between Alice and Bob, right? With the
Okay.
help of the TCP handshake in the correct order. So first of all,
Okay.
in the TCP handshake, the first step is to uh, send the SYN packet, right? So we'll
Okay.
send the SYN packet. And this is the sender, so receiver will receive the SYN packet and he will send the SYNAC packet that, yes, I am the correct receiver, right? So
Okay.
here, the SYNAC packet is, yes, I can hear you. Then after that, here the acknowledgement will be that, okay, great, okay.
Okay.
Then after that, uh, he will say that, yes, I can hear you. Oh, sorry, cheesecake on the sale. Like, what is the message? Like, after the connection has been established, now the Alice has to send the actual message, right?
Okay.
The actual message is this data, okay? And then he will say, I hear you, okay? And after that, uh, now the Alice will say, I am all done. Then he will say, yeah, I am also done, okay?
Okay.
Then after that, now the communication is also done. Now we have to close this connection, okay? So we
Okay.
will afterwards, after sending the SYNAC packet, we will just close this communication with the acknowledgement. Okay, goodbye. Right. So this
Okay.
was the flag. Did you understood the process?
Yes.
Okay. So next one is UDP IP. Okay. We will just okay. So UDP, as I told you, this is the user datagram protocol, right? So TCP is connectionless, right? Because there is no need of acknowledgement packet. And then advantages and disadvantages are like UDP is faster and UDP leaves the application whether it is the packet has been received or not. Okay, and UDP does not have any reserved connection. And the disadvantage is like that UDP doesn't care if the data is received, and it is quite flexible. And this means that unstable connection results in terrible experience. Again, so the important information are like time to live. So this is the expiry timer of the packet. Like uh, basically this sets the expiry time, like till how much time the packet will uh, transmit into the network. Okay.
Okay.
Then source address is the IP address of the device. Then destination address is the destination IP address of the destination. Then source port is the port number of the source, and destination port is the port number of the destination, and data is the actual data, right?
Okay.
So now we will come to the discuss the UDP protocol. Okay. So UDP protocol basically works like here, Alice and Bob. So Bob requests like I want to make a connection, or we can say simply he sends a message. Okay. Then Alice will respond the message. So here you can see that there is no establishment of connection, like there is no like sync acknowledgement. There is no this kind of process, right? Simply here the message is transferred. Okay.
Okay.
Yeah. So therefore this is the stateless, or we can say connectionless protocol. So we will just move into the question, like what does the term UDP stands for?
User datagram protocol.
Yeah, user datagram protocol. Uh, okay. And what type of connection is UDP?
Stateless.
Stateless. And then what protocol would you use to transfer a file?
Hmm, what protocol? Um,
Like we knew not like transfer for transferring file we used FTP protocol, file transfer protocol.
okay.
I think that should work. So let's see. Oh, it's wrong. So I think it will be TCP. Yeah, because we have learned in the previous topic like TCP is used for the transferring of file, then video conferencing, gaming, something. It was right written, right?
Okay. Okay. Yeah.
Yeah. And then what protocol would you use to have a video call?
I think UDP.
Okay, let's check this also. Yeah. So this is one more practical. You just go through it and you
Okay.
just try it also. Okay.
Okay.
Yeah. So let's finish this session then. Okay.
Okay.
Yeah. So was there any doubt in this topics which we covered today?
No, I understand it totally.
Okay. Okay, so you just do this two tasks which I have said one this one and I think previous was of the last topic, right?
Yes.
Yeah. So sure, we will meet tomorrow then.
Okay. Sure. So thank you so much.
Okay, yeah. Bye.